So what you need first of all, very first thing is that, as you can see on the camera, this one node MCU board. Okay, this node MCU board is required. Then USB cable is required with which you connect this node MCU to your no uh, laptop. Then next thing what you can see on the screen is the Arduino IDE. Okay, and this Arduino IDE I'm connecting this node MCU to this Arduino IDE. Now I just wrote a program and just now it is successfully running. So if you can see on the camera, this LED is blinking. On board there is one onboard LED is there, and this LED, if you can see my, because I am sharing the full screen on the meeting, and then my video is there, you will see this node MCU, this LED is blinking. Blue LED can be seen. So how we can do this? This is simple test that this node MCU is connected successfully, and it is accepting the command. Okay, so first I told you that hardware you need, a cable you need minimum, and then you need to install this Arduino IDE. So how to get the Arduino? Some of you might have done this thing from your previous, or I will just show you IDE, Arduino IDE. Right, so here you can Arduino.cc, this website you can go here and download this Arduino IDE, and this is one part you will need. Then second thing is that you will need the drivers. Okay, so here I will show you another thing, that is the CP10. And now how to get this thing? It is given at the back side of this your Arduino board, 1020102. Okay. So this driver here you can see I'm opening that thing on the screen, on the tab, it should be there. So USB to UART bridge VCP drivers are there. Okay, VCP drivers. Okay, so here you have to install this thing. Okay, so this from the download part, download and install VCP drivers. Here you can see Universal Windows X driver. So this driver is required to make the system detect this board. So how you will come to know when the system is, whether the system is detecting board or not? Here you have to go to device manager, and you see device manager on the screen, and here in the port, here you can see COM and LPT port. There you will see Silicon Labs CP20210X USB UART bridge and COM3. This line is very important, my friend. This line is very important. It shows that your node MCU drivers have been successfully installed and the device is now connected to the OS. Okay, means what? Now your PC can communicate with this node MCU on port number 3, COM3 port. You have to remember this thing, because now in your Arduino IDE you will have to configure your board, because you may work on multiple boards simultaneously. So again, going back to Arduino IDE, so here in this is, I have opened this simple program, in C program. So in the tools, you will see this thing. So where you will come to know, there you can say port. So currently, if I am connecting only one, that's why here you can, if you have multiple devices on which you want to flash the program, then you will see these multiple devices here. Otherwise, now as I have connected only one, then you will see this COM3 here. Then I have to select this COM3. Next thing is that in this board I have to select, here you can see the multiple types and what board I am having. So I am selecting node MCU 0.9 ESP12 module. In case node 32 is there, I'll have to select accordingly node 32. So already previously I have either worked on one node 32 ESP32, that's why it is visible here, and Arduino AVR boards. So as of now I am talking about this ESP8266 board, so I have selected that. Okay, and so it means what? Now here you can see node MCU 0.9 ESP12 module on COM3. Follow my mouse. Here mouse movement can be seen, and here it is saying that on COM3 I am having this node MCU 9 board connected. So as of now, here you can see these blinks are there. And now what we'll do, we'll write a program to bring the onboard error, means to check whether the things are working properly or not. The things are working properly or not. So what already I have tested, I was doing that thing. So tested and one program is perfectly running fine. So here I will show you this program can be seen here. Okay, so this ESP8266 blinker program is there. So whenever any node MCU program you want to write, these two minimum things are there, and beyond that you can write your modules here. Like no, like this thing. I'm writing one module here additional. Okay. So this is empty module, just for your understanding only I am putting. So what I am doing here is that, see, first before going to this, I will explain you what is the meaning of these two things: void loop and void setup. Void setup is here, void loop is here. So these are the two minimum, what you can say, modules you should be having in a program where you want to perform something on this node MCU. So we are actually programming a smart thing. We are actually programming a smart thing. This is a smart object, smart thing is there. We are programming that thing. So what I am setting in the setup part in this node MCU or this Arduino programming, you have to configure the input output lines. Okay, what are the, even if you want to, I have big program also display another thing. So this setup part we have to put it here. So what I am doing, pin mode LED built-in output. So built-in LED which is on the onboard is there, blue LED, and I am setting this thing at output. If you want to use, what you can say, your IO pins, then accordingly you have to set the pin mode for this IO pins as input or output. So if you want to read it from that pin, suppose if you want to read data from the sensor, then you have to set that sensor pin as input. Means suppose you want to read the BME280 data. See, this BME280 is here, and this I connect to this IO pins are there, and for example D01 I am connecting. So D01 is somewhere here. Here you can see D0, D1. Here these pins are there. So I want to connect this thing. So I will set that in according. So actually this is first very simple program. So what I am doing, this LED built-in output, I am saying that okay, I want to blink this LED, treat this thing as output. Then here you can see now this function is digital write LED built-in low, means what, we are switching off the LED. Then we are having certain delay of 500, 1000 milliseconds. This delay is in millisecond, and then digital LED built-in high, and then wait for 2000 milliseconds. So what we'll do, I will show you how I can increase the flash rate of, I will increase the flash rate. So we'll have this 500, and then we'll wait for 1000 millisecond here. So now this flash rate should be now changing. So what, this is this program modification I have done. So in the loop part means what, as this is the firmware, it has got its firmware. Our program has to, it is not like that once the program is executed and it stops. So because this is a microcontroller and things have to be done repetitively. For example, you may want to read the sensor data every 10 seconds. You want to read the sensor data every 10 seconds and upload it for on the cloud. So this loop subroutine, it goes on executing again and again and again. Okay, continuously. So that these functions are here on this node MCU, they will keep on executing with that delay. So what will happen? LED built-in low, it will switch off, wait for 500 millisecond, then it will switch that on for 100,000 millisecond, again off on, off on. It will loop. So that is the meaning of loop. There you can see this LED on this previous program was 1 second, 2 second delay and 1 second off. So it was it is simply, there is no for loop but or while loop, but still this LED is continuously blinking on and off. Okay, you can see here. So that is because I have written that thing in the loop function. So now I have modified that. So this is as good as now I am giving you new demo. So this function, this program is done. So let me say that okay, sketch. So actually these programs are called as sketch in Blink Arduino. So sketch, I will say verify, compile. So now I'm compiling that whether things are okay or not. Simple C programming base syntax is there, and it will take now. It will do the compilation. task. So it will check for that boards, that processes, whether your activities are no as per syntax or not. So that thing is doing for this specific board. This IDE is compiling the program. This is for first time when you want to flash this program on this Arduino board. So then when you say upload means flash, it will compile and flash. So it is not like that. No, every time you must compile. You have to compile when you are actually writing and testing program. You have to compile. But when you are uploading, you say that okay, it is final, corrected, and I want to upload. Then here this option called as upload. Can you see this upload? So I am uploading. So uploading to what? Node MCU ESP12 module on COM13. On this module I am uploading. So I will say now upload. So on the screen it will start uploading process. Here you can see. Now it is again compiling, and once this it will compile. Already we have done compilation, but still upload. Before uploading, it compiles the program again. That is the integral protocol part of this process. Yeah, so compilation is done. Now it is connecting. So here you can see it is identified the chip 2.6 megahertz. This chip is there, and now it is flashing the program. You can see that the flashing has started. So program is now getting flashed. Now when the flashing will complete, it will reset that thing, hard resetting via RTS pin. Now if you observe, this blinking rate has increased. You can see now blinking rate for this LED has increased because we have reduced the delay. So our program is successfully running on this LED, on this node also. So it is now working on that. Whatever the instruction this LED is, now blinking rate has increased. Similarly, you can write other programs, other subroutines. Then there are many packages. For example, if you want to monitor this, what you can say, board on your mobile phone, there is what you can say, a blink framework is there, and you can use blink framework to whatever sensors and health status are there on your mobile dashboard. Some of the services are free, some of the services are paid accordingly as per your requirement. So you can do that. So for smart home kind of process, you can use Heroku and Blink for cloud based application and mobile based interface. So you can see the sensors and value on your mobile phone, and as well as you can schedule this, what you can say, uh, no cloud based service like SMS or email, or sending mail, sending SMS, sending data on cloud, storing data on cloud, analytics. Then all those things, what you can say, you can do it on this online cloud services. So that is a different altogether part that can be done. You can put all this processor and subroutine for that, and things are on index. So this is a very, it is like ABCD of your node MCU programming. So we can start our project with that. So just checking here, you can see this is the must when you connect your node MCU, and when your driver are there, this COM3 and having this device recognized by the Windows, this is important. And then accordingly, next step I told you that we have to select the COM port, and this COM3 is here. You can see means what, whatever the device which is connected to our system is actively uh, identified, and now we can program or flash that thing. Again, I will show you. Yeah, so there is one reset button on this board, so you can reset your, if it is for some reason if it is not starting, then you can simply reset using by pressing this thing. Okay, so it resets that UP. Now this machine is connected, taking power from this node MCU, or this object is taking power from my USB, and it is independently running my flashing program. So things can be continued like this thing. Okay, so yes, this was this. Any question here, my friends? Any question you have, you may please ask. You can ask the questions. The students who are attending, you can ask the question. Any question, any doubt you have? What to do, how to do? Okay, let me take. Yeah, let me stop this streaming. Thank you all. I'm just stopping the training. uh, streaming.